In this video, we'll talk about comprehensions in Python. Comprehensions are basically a compact way to create data structures from a formulaic template. We have comprehensions for the basic data structures such as lists, dictionaries, sets. So we'll talk about list comprehensions, we'll talk about dictionary and set comprehensions as well. Let's take a look at this example now. In this example, I'm constructing a list stepwise by starting from an empty list and then in a loop that goes over number from 0 to 11. I'm appending the square of each number to a list. So I get a list that contains the squares of numbers from 0 to 11. Now we can notice that in order to construct this list, there were three important ingredients. One of them is the expression that we wanted to fill in each step when we created the list. Now second, this expression depended on a variable, in this case the variable n. And third, this variable had to range over a certain range. In other words, this variable had to have some multiple values that it ranged over. Now those three elements can be compactly represented in a list comprehension. Instead of starting from an empty list and filling this list step by step, we write a list comprehension as the following. First, we start with two square brackets indicating that we want to construct a list. Now in contrast to filling this list manually, notice here that we are not associating, we're not filling in, we're not listing items one by one with a comma. Instead, we have a template, we have a formula that fills in this list. And this template is a list comprehension. The three ingredients are here. First, we need the expression, which is n to the power of 2. Second, we need the variable, which is usually plugged in this expression, n in this case. And third, we need the range of values that this variable takes, which is range 12. So you can see here it's very similar in the for loop syntax. We basically have expression for variable in a range or a variable in a list or something that has a range of values. The end result is having the same list, but we have created this list using a list comprehension, which is a very compact way to creating the list. We didn't need to worry about initializing the list with an empty and appending the elements one by one. So that's basically the basic syntax. A list expression for variable in iterable. And iterable can be a range, it can be another list. Anything that we can iterate over in a for loop is a valid candidate here. Let's take a look at some of the more advanced examples here. We're not limited to one loop. We can basically have multiple iterations. So for instance, in this example here, I'm populating my list with a tuple of ij for I in range 2, for j in range 3. So first I will vary, so I will be 0. And within each iteration of I, j will vary from 0 to 2. So I is 0 here and j is 0, 1, and 2. Next, I will go to B1 because it ranges over 0 and 1, range 2. And then j will take the value 0, 1, and 2. Now notice that this can be any expression. Usually the expression is related to what we are iterating over, but it can be any expression. For instance, if I put here hello, simply speaking, I will get hello repeated 6 times because I will range over 2 values, j will range over 3 values. If I put I times j, I'm going to get the multiplication of I and j. When I is 0, the multiplication is 0 all over the place. When I is 1, j is 0, j is 1, and j is 2. So that can be any expression, and usually the expression has something to do with what we are iterating over. Similarly speaking, this can be a range, it can be also another list. So I can do for I in 5 and 7, for j in 8 and 9 in this example. Anything that we can iterate over is a valid candidate here. Now, one way to think about this expression is that we're trying to apply something, a function here, to what we are iterating over. So a list comprehension basically allows us to have some expression in mind, some function in mind, and make the function operate on what we are iterating over. So in this example, we can think about having a function that takes two numbers, I and j, and return a tuple. Okay, so what we're doing basically here, we are applying this function on the variables f and j. This is something we will get back to later on, but list comprehension is very useful if we want to apply a function over a list or over a ranges of value. The list comprehension also has some other features. We can put conditionals in the iterators. So for instance, we can say that we're not interested in all of the ranges, we're only interested in the value in the range that satisfies some criteria. And this is an optional if statement that we can put in the list comprehension. Again, this part is optional, but we can have it. In this example here, we're saying, well, value for value in range 20. If I take out the optional if statement here, you can see that we've got numbers from 0 to 19. This if statement says, well, I'm only interested in those values when value modulo 3 is greater than 0. It basically says leave out multiple of 3, because if value is multiple of 3, the modulo 3 will be 0. Effectively, this if statement is filtering the list based on some condition. This is very similar to saying, well, creating this list manually step by step and having an if statement within the loop that populates this list. Now let's take a look at another way to incorporate an if statement in the list comprehension. If you're coming to this course from Java, you've probably seen this conditional operator. This conditional operator basically evaluates an expression, and based on whether the expression is true or false, it can return two values. This conditional expression, the single line conditional expression, exists in Python, but it has a different syntax. This is its syntax. Value, if value is greater than 0, else minus value. So basically we evaluate the condition here, and if the condition is true, we return this part. If the condition is false, we return this part. This conditional expression has nothing to do with list comprehension. It exists as a Python construct, and we can use it outside of list comprehensions. But it's possible also to use it within list comprehensions. For instance, my expression here can be a conditional expression. What I'm saying here is that, well, depending on whether value is modulo 2 is not equal to 0, because this will evaluate to true when it's not equal to 0, put value. Otherwise, put minus value. So what we end up getting here, let's take out this optional if here. We end up getting numbers from 0 to 19, but the multiples of 2 will be negated, because multiple of 2, this expression will be 0. It means it's false, so we'll get to the else part. This is basically the expression we're applying on value. This conditional if statement is filtering these values. It's basically saying take out the multiple of 3's, what we have seen above. So only if value modulo 3 is not equal to 0, which means not multiple of 3. So this list comprehension looks at all numbers from 0 to 19. Multiples of 2 will be negated, but it also filter out numbers which are multiple of 3. So what we have talked about so far is a list comprehension, and it's a list comprehension because we are including this comprehension expression within two square brackets. If we include this comprehension within two curly brackets, then what we get, we basically get what we call a set comprehension. So here we're creating a set which is the squares of numbers from 0 to 11. And you can see that the result here is a set. Now in this example we get exactly the same numbers in the list because there are no duplicates. But let's take a look at this set comprehension. This set comprehension is basically looking at all numbers from the range 0 to 1999, so range 1000, and it's only looking at the number modulo 3, because if you take any integer and do modulo 3, you'll get either 0, 1, or 2. That's what you get in a set comprehension. Had this been a list comprehension, we would have gotten 0, 1, 2, 0, 1, 2 repeated 333 times, because it's dividing this number modulo the number over 3 from 0 to 1999. But if I make this one a set comprehension, it's going just to keep the unique values here. Let's take a look at this comprehension here. It looks very much like a set comprehension, but it's not. You can notice that here we have associations. Thus, this thing is a dictionary comprehension. It basically creates a dictionary by associating n with a square of n for n in range 6. So what we get here, we get numbers 0, 1, 2, 3, 4, 5, and each one is associated with its square value. Comprehensions are a shortcut to create a data structure, such as a list, set, or a dictionary. Conceptually, we can think about the comprehension as doing two things. First, it's applying an expression or a function to a variable. Second, it's looking at different values of this variable. So we can think about the comprehension as applying a function on a list of things. This idea of applying function on a list of things is called mapping. Mapping the function to values in a list or values over a certain range. We also have seen that it's possible to have a condition within the comprehension, so we can filter out some of the values that we wish not to include in the list and keep the ones that we want to include. This step is called filtering. Now, mapping a function to a list and filtering items in a list are two essential functional programming concepts. In functional programming, we try to write our programs as a sequence of functions, and those functions operate on variables, single values, but they also operate on sequences or lists or collections of values. So it's very often possible to write a data analytics program as a sequence of functional processing, and those different functions operate on the data, changing it. Now, the last functional programming function, which is not something we can do with a comprehension, is called reduce. It basically reduces a list to a value. So I'm including this here for the sake of completion, but you can think about the reduce as a function that basically takes a list and give you back one single value. I imported the function reduce here, and basically I'm reducing this list to a value using the function which is add. Basically takes two elements and add them together and you get one value. So this is similar to saying something like this: sum is equal, s is equal to 0 for v in 1, 2, 3. Sum is equal to sum plus v, and at the end of the day sum is 6, right? That's similar to saying reduce this list using the function add, and the function add is a function that takes two parameters and then add them together. So let's take a look at this example here. Say, for instance, I want to blank out emails from this text here. Now, we have seen this before. We have seen the function mask and the function is email used together to blank emails from a text. Now here I'm trying to use functional programming concepts such as mapping, filtering, and also reducing to do this. Let's take a look at this step by step. Here is my text message. So what I'm going to do in the first step is to basically split this two words. So message.split words is going to give me, sorry, message.split is going to give me the list of the words here. Okay, so this list of words, I'd like to filter out some of the words in this list. So the way to do it is to basically write a list comprehension that construct a new list from this list. That's the basic syntax of the list comprehension. This comprehension doesn't do anything yet. It basically recreates the same list of words here. Now what I can do here, I can do any transformation on the word, and I can filter word here. My filtering step is basically saying if at not inward. That basically says if at inward, just take it out from the list. And as you can see here, the emails have disappeared. The next step is to basically join this together to create a string. So I can either use the function join space dot join this list and I get a string back again, or I can use a reducer. As you can see here, my reducer is basically given two words, add up the two words together with a space in between. That's the function that I want to use when I reduce this list. So if you take a look at this expression, we've got a simple mapping. There is nothing here doing when we are mapping. We're basically keeping each value as is, but we have a filtering based on whether at is in the word or not. And then we're reducing this whole list to one value, one string value, by adding up each two words with a space in between. Another way to do something similar is to say, well, okay, I'm not going to filter this list, but I'm going to map a function here to my word. And this function will basically either masking the word if it's an email, or keeping it as is if it's not an email. So I'm going to say, well, if it's an email, if at inward, I'm going to do len word times the masking character, else if it's not an email, word here. And what we get here, we get the same thing here, except that when we have those two words, we have stars because they have been masked. The difference in between this one and this one is that this one doesn't filter the list, but it basically applies a function on each item in the list. The remaining is the same. I either reduce it to one value using a reducer function, or this function already exists in the string method, so I'm not going to worry about it. I'm just going to join this list of strings with spaces here to get one string here. So that's to say it's possible to think about this data processing problem, getting from the input to the output, as a sequence of multiple functions, and those functions, conceptually speaking, will be either mapping, reducing, and or filtering.